In today's data landscape, the journey from raw data into actionable insights is complex. You are constantly extracting data from multiple sources, transforming it with custom logic and loading it into warehouse like BigQuery. This is a world of ETL and it requires perfect orchestration. When dealing with dozens of dependencies, schedule runs and potential failures, traditional scripts quickly become brittle, leading to manual interventions and delayed insights. You need a dedicated scalable conductor for your data orchestration. The conductor is Google Cloud Composer. Today we are diving deep into how Cloud Composer empowers you to build robust, scalable and manageable ETL workflows, all within Google Cloud. At its core, Google Cloud Composer is a fully managed service built on open source industry standard Apache Airflow. Airflow is a platform to programmatically author, schedule, and monitor workflows using standard Python code. It focuses on defining workflows as directed acyclic graphs or DAGs. But the key differentiator is the cloud part. Composer takes the complexity out of managing Airflow infrastructure. No more provisioning Kubernetes clusters, managing database backends, or handling scheduler resilience. Google Cloud handles the entire lifecycle. This means your data engine is focused on writing powerful, reliable ETL logic, not operational toil. Composer ensures your Airflow environment is highly available, automatically scales its workers to handle spikes in workload, and simplifies version upgrades. Composer environments are deployed with seamless security and network integration into the rest of your Google Cloud environment, making connection to services like BigQuery, cloud storage, and data flow secure and straightforward. Let's look at the anatomy of an actual ETL DAG inside Composer. A DAG is composed of tasks which are defined by operators. We are just taking an example here. Extraction might involve the Google Cloud Storage to BigQuery operator, which pulls data files into your warehouse. For the transformation step, you have maximum flexibility. You might use BigQuery operator to execute complex SQL scripts directly inside BigQuery, taking advantage of its serverless compute power. Or for complex large-scale Python transformation, you could use the data flow operator to trigger an Apache Beam pipeline. These are very few examples, but we have many more options to perform this step, which depends on our requirement. For loading, the BigQuery operator might be used again to finalize the tables, or perhaps an HTTP operator to push a summary metric to a visualization dashboard like Looker. All these tasks are linked by dependencies defined in Python. This guarantees that your transformation step never runs until the extraction is complete, and the final load only happens after the transformation succeeds. The control is crucial for data integrity. Furthermore, Composer handles retries and failures notification automatically. You define the behavior right in your Python code. Here is an example. If a BigQuery job fails, Airflow can automatically wait a set time and try again. And if it still fails, sends a notification via Slack operator or email. One of the most powerful reasons to use Cloud Composer is its deep native integration across the Google Cloud ecosystem. Here we see a few examples. Need to process streaming data before analysis. Composer can trigger a Cloud PubSub subscription to start batch processing. Need to run custom code without managing a server. It seamlessly triggers cloud functions or cloud run jobs. This is achieved through the extensive library of Google Cloud operators, pre-built tools that handles authentication and interaction with dozens of GCP services, eliminating the need for boilerplate code. For security, Composer leverages Google's IAM for service account access. Your DAG operates with the principle of least privilege, ensuring that workers only have permission for the specific services they need to interact with, maintaining a robust security posture across your pipeline. The Airflow UI itself, which you access via Composer, gives you live access to logs, historical run data, and the ability to manually trigger or clear tasks. Powerful control at your fingertips. Beyond standard ETL, Cloud Composer scales to handle advanced data engineering needs, especially in the realm of machine learning operations or MLOps. Composer is often used as the orchestrator for end-to-end ML pipelines. It handles tasks like extracting training data, triggering a notebook run on Vertex AI workbench, launching a Vertex AI training job, and finally deploying the finished model to serving endpoint. For monitoring, Cloud Composer integrates directly with cloud logging and cloud monitoring. This means all task logs, performance metrics, and environment health data are instantly available in the standard Google Cloud interface, simplifying diagnostics and alerting. Furthermore, Composer environments are versioned. You can deploy updates, test new DAGs in isolation, and roll back changes if necessary, providing operational discipline often required in regulated industries. This comprehensive set of tools, combined with the power of Python and reliability of Google Cloud, makes Cloud Composer the definitive choice for orchestrating mission critical ETL and MLOps workflows. Stop struggling with scattered scripts and unreliable schedulers. Take control of your ETL processes. Google Cloud Composer delivers the operational excellence and programmatic power of Airflow minus the management overhead. Ready to simplify your data orchestration and accelerate your data team? Explore Google Cloud Composer and start building your first fully managed DAX. Alright, let's get into action. In this first step, we are going to create a Composer environment and we will do it quickly and efficiently. If you would like a detailed walkthrough on creating a Composer environment from scratch, I would recommend checking out our earlier video. We covered that in depth in this video. Now let's begin. Go to the Google Cloud Console, open the Analytics product group and click on the Composer product link. This will take you directly to the Composer specific console. Next, click on Create Environment. Make sure to select the latest Composer version, which at this time is Composer 3. Give your environment a meaningful name. Then choose your nearest region and the latest image version. Go for the stable release as that's generally recommended. Next, you will need to select a service account. This service account allows Composer to access other Google Cloud services securely through IAM permissions. For best practice, you can create a dedicated service account and use it here. Now let's choose the resilience mode. As mentioned here, high resilience is recommended for production environments. But since this is a demo, we will go ahead and select zonal mode. For environment size, we will keep it small as this setup is just for demonstration. You can also notice the workload configuration details here. Compute and memory resources will adjust automatically based on environment size you choose. We will leave all other options as default for now. Let's go ahead and create environment. This process will take a few minutes, so sit tight while Google Cloud sets everything up for us. Now that our environment is created, let's move ahead. I have already covered the Airflow user interface, the DAX, folder structure, and other related Composer components in detail. So if you would like a refresher, make sure to check out the video link provided in the description below. Here you can see our Airflow UI, where all our deployed DAX are listed along with their current statuses and operations. This is the DAX Cloud Storage Bucket folder, the place where we actually upload and store our DAG scripts. This follows the standard Composer practice. Every DAG you create and deploy lives right here inside the GCS folder. Now it's time to put this setup into action with a simple demo use case. Here what we are going to build. We will extract raw customer sign-up data from cloud storage CSV file, perform a lightweight transformation to clean and structure the data, and finally load it into a BigQuery analysis table, which can be further used by downstream system for analytics and reporting. So let's dive in and see how we can orchestrate the end-to-end ETL workflow using Google Cloud Composer and Airflow. Our pipeline has three strict steps, all defined within a single Python DAG. First one, wait for the file. Second step, load the file to BigQuery. The final one, run a final SQL transformation. We have created this GCS bucket for our demo and placed input data. Let's look at the data. Our raw input is a CSV file saved in cloud storage bucket. The first crucial step is ensuring the raw data file exists before starting anything. We use an Airflow sensor operator for this. The code snippet uses the GCS object existence sensor operator. It simply pauses the DAG run, checking the Google Cloud storage bucket every few minutes for our file existence. This prevents errors and wasted compute time. Once a file appears, the sensor succeeds and the DAG automatically moves to the next task. Now that the file is ready, we load it into a staging table in BigQuery. We don't need any code. We use pre-built Google Cloud operator, that is GCS to BigQuery operator. This operator takes the file we just found in GCS and loads it into a temporary BigQuery table called raw customer staging. We have created two datasets for this demo. The first one is called raw data, where our raw customer staging table will be created to store the extracted raw data. The second dataset is named analysis, which will contain the finalized process table after all transformations are applied. The key parameters here are auto detect equal to true to infer the scheme. The write truncate, which ensures we start fresh with each daily run. A single task replaces lines of boilerplate Python or manual console clicks. The final step is running our transformation logic. We want to clean the data and derive a new field called platform from the existing data source column. We use the BigQuery insert job operator to execute a raw SQL. The power here is that the transformation happens inside BigQuery, taking advantage of its immense processing power, entirely separate from the Composer workers. The SQL itself is a simple one. We use a case statement to map the raw source data into clean platform names and assign a default segment. We define the task dependencies. The load step must finish before the transformation steps begins. In under 30 lines of declarative Python, we built a reliable, fully managed ETL pipeline. We leverage a sensor to wait for the data, a GCS to BigQuery operator to handle the heavy lifting, and a BigQuery operator for scalable transformation. Composer handles the scheduling, monitoring, and scaling. You handle the logic. That's the power of orchestrating your ETL with Google Cloud Composer. Now our DAG is ready. Let's deploy this DAG into Composer's DAGs folder. Once the file is uploaded, Airflow will automatically detect and pick it up for execution. Since our input file is already available in the specified GCS bucket, you will notice the tasks begin to run one after the other, completing in sequence. If we need it, we can re-trigger the DAG manually or simply clear the first task to run the entire pipeline again. Now the DAG run has been successfully completed. Now let's verify the output in BigQuery. Open the BigQuery console and check the staging table created in the second task, as well as the final cleansed table generated under the analysis dataset. Ready to simplify your data operations? Start with your first Composer DAG today.